ANSYS VR Experience brings the driver in the loop for human factors engineering. Connecting real people with virtual simulated vehicles, this solution enables to assess and anticipate drivers' reaction in any driving situation. VR Experience recreates a lifelike context to foster drivers' immersion, including realistic driving simulation and scenario and traffic variation. As the shift from automated driving to manual driving, as experienced by the test drivers in an accurate and interactive virtual cockpit. From this, it is easy to monitor situational awareness into the vehicle and the related human reactions, including the emergency management and the takeover efficiency, and to anticipate situations of foreseeable misuse. Virtually test and improve the vehicle feedback according to the test driver's behavior and takeover time for digital, visual, and audio warnings.
Good afternoon, ladies and gentlemen. My great honor to welcome you at the first FISITA Web Congress in the name of the Czech Automotive Society, which organizes this event together with FISITA, the international membership organization for the automotive and mobility system engineering community. My name is Ondrej Marcelin, and I'm professor at the Technical University of Ingolstadt and president of the Czech Automotive Society, FISITA member society in the Czech Republic. Before asking Professor Jan Macek to begin with his welcome, let me to share some organizational items with you. Let's start with the discussion, which will be arranged at the end of the keynote session for all presentations together. I would like to encourage you to ask your questions in the Q&A panel. However, please do not remember to change the addressee to all panelists. The technical part of the Congress consists of more than 60 papers, which you will be able to download from the FISITA web starting tomorrow. Many authors accompany their papers also with video tracks. At the end of my opening, I would like to acknowledge the company ANSYS for being partner of the FISITA Web Congress 2020. And now, I'm happy to ask Professor Jan Macek from the Czech Technical University in Prague to begin with his welcome speech. Jan, the virtual stage is yours.
Distinguished keynote my screen for a moment to start this unusual event. I answer some of the situation that web at people is of regularly run FISITA Congress 2020, which was postponed due to weather reasons. And it is important to answer why this web congress is. I think that we should rely that automotive research never stops and cannot be or must not be interrupted by turbulences. And this never stopping development based on exchange of views. You will have an opportunity to listen to keynote speeches which are focused on current position and the future of automotive industry. How to do it? I think that engineer using unbiased and holistic assessment of possible solutions. We should be far from soul phase and voluntarism, which is not based on the laws of nature, and we should try to find a compromise among all variety conditions to which vehicles and mobility tools are subjected to. It is only a technical background, but we know very well of us that very famous V-shape going from concepts to details of parts and then back to product any software company, any developer in automotive industry knows for today very well. Front loading by means of simulation and predictive methods is very important to accelerate the concepts. What is so very often used in such a structurized way is a way from product over market to life cycle course operation, which causes side effects, and these side effects are reflected after some time by societal demands, by governmental or higher level regulations, and also customers' expectations based on media presentations and so on. And this is in fact such an A-shaped roof for this well-known V-shape. Of course, the management of any OEM and any supplier of parts, and intuitive for scientific based from this A-shaped is used. But what we need and what Congress stress is that we need very strong feedback to this left-hand branch of A-shape because the natural feedback, which is caused by loss of niche, is too slow. So faster feedback from the reality, from the feasible solutions should be applied to the regulations and customer expectations. So I hope that we can a little answer those questions by papers which are will be available first of all by keynote speeches which will now follow. The first one, as you can see, will be Ivan Horáč, followed by Christoph Gimbel, Dino Flor, Dirk Lappe, and at the end, Martin Hrdlička. And we are looking forward for the following discussion based on as it was already on Andrzej Vaculín. So the first referee of keynote lectures is Ivan Horáč, and I would like to ask him to start with the lesson.
speech, and I'm not going to talk about technical issues. I would like to put the situation in which we are today into perspective. The industry is probably going through its most important transformation ever since I remember. And the challenges that we have today are enormous. Let me enumerate them. We know them, but I would like to put them into perspective so we understand in which framework we operate today. In the first place, I think that we should and we cannot avoid to mention COVID-19. The COVID-19 for me is a short-term challenge, short-term problem. We all know, we all hope is going to go away. But from the situation, we have learned several things that we will use moving forward. First of all, as far as the numbers are concerned, Europe, United States, and other markets are expected to be down 20-25% in 2020 as compared to 2019. China is growing already. We have the same or similar situation as we had 2008, 2009, but the downfall in Europe was slower, and China was growing at that moment 30-40%. So we are basically saved by the whole thing through the development in China. What's important to remember what happened to us in those in these different times and happening, and what the industry has to remember is some key issues. First of all, it's important in those crises is to retain the qualified workforce. We cannot do without it, and I know that all the companies are doing what they can to do that. Second, and we have seen that, and it's now starting. We want to bring the key supplies home. We cannot afford to have key suppliers too far away from the production, so we will see clearly a movement of the suppliers to the place of the production, and the manufacturers, the OEMs, will have to make sure that the suppliers survive. The supply has to exist and has to function. If it's not going to function, the industry cannot function. Last but not least, and I'm going to finish this part on the COVID, is that, and as indirectly mentioned before, we have to have enough of money for research and development. And when we see what is waiting for the industry on the other side, on the technical and other issues, we need desperately finances. We need people. We need human resources to continue the R&D that is essential for the survival of this industry. So again, COVID-19, one of the key programs, but a short term. The second one is the environmental pressure. The environmental pressure will not go away. The pressure from the government today, it's different in different countries, and it's different in different regions, but the pressure is there, and the pressure will come also later on, obviously, from the customers. Today, we see the quick development, in a certain way, market penetration on battery-driven vehicles and on plug-in hybrids. But 85% of these cars are being sold in China and in Europe. So concentration of the technology that we know today that we can use to meet some of those environmental challenges are very much used here. Despite all these developments, despite what the industry is doing, we still don't have infrastructure. We have been calling for building infrastructure, charging infrastructure. We don't have it. I'm not going to buy an electric vehicle if I charge it either at home or in the front of my house. That's the bottom line. There are other aspects as well. What it is today also very much, it is a push rather than pull market. The battery operated vehicles, let me call it electric vehicles, are pushed into the market through incentives. We see the success of Norway, we see the success in other countries, but all this is done through incentives. The question that we have to ask ourselves is what will happen when the incentives one day and will one day disappear? So we have to make sure that the market, which is to the push market, becomes clearly a pull market. I also personally do not believe that the technology, the electric vehicles as we know them today, will be staying with us for more than 10, 15 years. There will be new technologies. We are looking at hydrogen, but the experts will come to it. In this segment, what is extremely important is to be able for the industry to create the framework, the regulatory framework in which operates. And the legislator may not push the industry to a situation where it loses competitiveness and when it will lose its possibility to invest in other obligations, other things that we have. The next issue, the next game changer, the next challenge today is the mobility. Mobility is going to be a service. It is going to change. Companies will be selling mobility, and we are seeing it already today. Car sharing and other services are coming, but it will be more and more pronounced. We have to realize that irrespective of whether it or do not have, that we are in an economic and situation which we are. The young people today do not want to own cars anymore. We see it in Japan. The status symbol is not a car; it's an iPad, and it's coming in Europe and it's coming in other places. So this car sharing, the non-ownership, with maybe the exception of the upper segments, is going to change. What this will mean? It will mean that the market, the car park, will change. I am not necessarily saying that there will be less cars being sold. Probably yes. Cars will be used in a different way. Today, a customer is driving 15,000 cars, 50,000 kilometers a year. Now, this car will be used by 5 or 6 people, so we are looking at 100,000. You, the engineers, have to figure out how a car that that is driven 100,000 kilometers a year will stay here for several years. After 3, 4 years, such cars are basically put into the waste basket. And we saw also that in big cities, the cars are not necessarily welcomed, and then I'm very nice to say that. Cars are being pushed out of the cities. And we are going to use public transport as long as the public transport is going to be developed. Again, a need for new services, mobility services, and this is with us. This is the future that we are going to see, and we have to clearly adapt to it. The autonomous vehicles are going to push these services even more into the market. 30% of customers in big German cities today are willing to buy or to use autonomous vehicles for their movement inside the cities. It will be probably different outside. The next issue which we are facing, the next important challenge, and I cannot go through all of them, obviously, is the arrival of autonomous vehicles. The industry has created an expectation as if the autonomous vehicles will be here tomorrow. I remember in 2012, some leaders of this industry were saying battery electric cars 2015, 2020, and 15, 20% in 2020. It's not. We can't name it autonomous vehicles. The customer today thinks that the autonomous vehicles are there. they are not there. They still need a lot of development. They need infrastructure. They really need a cooperation between the traditional market producers, the traditional OEMs, and some of the newcomers, also different companies like Apple, IBM, etc. And this is happening. It also has enormous amount of money. We have been through it before. I have mentioned that, and it will also require one thing that I will come back to later on, and it is a need for global harmonization. We need harmonized standards. Excuse me. We need a harmonization of standards there where we can. We have been through this before. We have been mentioning before, but we are still there. Another aspect that is extremely important, very often forgotten, are the trade issues. This industry cannot afford a trade war. This industry cannot afford trade frictions. We have seen it. We have also seen how much we have tried to find a deal between the United States and Europe in the framework of TTIP. We have seen how we try what great Brexit, and unless we will be able to deal with the trade issues, we will suffer. Here I coming back to what is extremely important for me, the harmonization of standards. Yeah, the easy ones. The easy ones are the charging standards. The more difficult ones are the standards for emissions, and the difficult ones will be one for data sharing and for the autonomous vehicles. I will give an example of a very recent development that is going to change a lot of things. You have seen the new deal that has been struck between China and South Korea, Japan, Australia, New Zealand, and many other countries in that region, and maybe in the future in India. This big conglomerate, this big free trade agreement, it covers today 1/3 of the world GDP, and it covers also almost 2/3 of the car market, of the car production. We have been talking about standard setting, and we have to make absolutely sure in Europe and in the United States that in one way or another we get together and we start working on harmonization of standards. Otherwise, all these standards are going to develop in Asia, and we are only going to copy them. So the trade issues are extremely important for us, and are very often forgotten. The last one, as I have mentioned, is deal in the Pacific Rim is extremely important. There are other issues, other challenges, such as competition from newcomers, and we are forgetting it. There is the race for the fuel cells. As I mentioned before, the battery-operated, battery-driven vehicles are not the final technology. The question is when we are going to get to the next stage. And again, this we can do only through a cooperation. In conclusion, the challenges that industry is seeing today are unprecedented. It's COVID-19, it's environment, it's mobility, autonomous vehicles, trade-related issues. And the only way I believe that we can solve these problems is in enhancing cooperation among manufacturers. The resources that will be needed to develop the new vehicles, resources that will be needed to develop the autonomous vehicles, and to meet the expectations from the environment side, will be very costly, and we cannot do it otherwise than in cooperation. We have to get, we see today there is a cooperation between China, Europe, Japan, United States, South Korea, the company working together. But it's not enough. We also have to work with the authorities. It's extremely important that industry speaks with one voice to the authorities. So the authorities will create a level playing field, a regulatory framework in which the industry in which the industry can operate. And if we are not going to do this, we are going to have lots of problems. So I will conclude my 15 minutes speech. I'm sorry for my voice. It's coming back suddenly at the end again. I think we are living in a situation where we are facing challenges that we faced before. It's a combination of the economic situation, of a political one. I hope that with the arrival of new administration of the United States, we are going to start a better cooperation between Europe and the United States. I'm sure about it. And the environmental other pressure that we need to solve. So good luck. I'm sure that we will get through it. The issues are extremely important. They are serious. When you engineers, when you are looking for your solutions for your problems, you need to understand the context, the political economic context in which the industry operates. Thank you very much.
Thank you very much, Mr. Hodaj, for a very inspiring lecture. And we will continue with tools how to accelerate development. Very important for reacting to this challenging time. And I would ask the first of you to start with this lesson.
Yes. And see. Yeah, right. That was just a perfect introduction to my presentation, but to what I would like to show you. So just would like to start here. Yeah, I think because time is so tight, I would like to jump directly into the topic and show the first slide. This slide was just mentioned by, or explained almost from the Hodaj. So what do we see? We see a lot of pressure that is generated by legal requirements, these CO2 limits or quotas for importers with respect of electric vehicles, or the discussions in many countries to ban ICE vehicles, which starts in Norway. We had the discussion with UK. They said, okay, they want to start in 2030. We had the discussion with California, New Jersey, New York. They think that they will start to ban ICE vehicles in 2035. And it was also just mentioned that many cities would like to ban ICE cars as well. So this creates a lot of pressure, and we see this. I've had some quotes from three CEOs. Herbert Diess, who is the CEO of Volkswagen Group, says the world is on the move. The storm is just beginning. The big question is, are we fast enough? or Markus Duesmann, the new CEO here with Audi, says Tesla is 2 years ahead. When he says officially 2 years, perhaps it's a little bit more in terms of computing and software, and in autonomous driving as well. And Ola Cornelius, CEO from Daimler, says there will be no keep on like you have been doing until now. So we see a big shift from the traditional engineering and to a new world which is driven by digitalization. So the question is, what happens with the new players? Also just mentioned, like Rivian or Neo, Rimac, Lucid Motors, iWays, and others. They normally have limited resources and they have no traditional development center fully equipped with extremely high sophisticated test facilities, and in some cases still no positive free cash flow. So they are forced to use the most efficient tool, and they're using intensively computer-aided engineering tools. In January, I visited again Peter Rawlinson, who is CEO and CTO of Lucid Motors. I know him since a couple of years, and if possible, I love the discussions with him. So he said, okay, we learn so much more from a virtual prototype than from a physical prototype. The reason why we can accelerate development is why we have great confidence in the fidelity and velocity of our computer models. Yeah, so what happens with CAE? CAE is now in a strategic position. What we see in general is we have the status quo that is we did with combustion engines and the classical way to develop cars. Then comes the EV. The EV is a little bit simpler. Has no exhaust pipe and things like this. They have other challenges, but they have less parts. What we see in addition is shared hardware and software. A nice example is the MEB platform from Volkswagen, which will be shared together with Ford. Another example is software which it's using from Polestar. Polestar is using Android Automotive. What comes in addition, it's the over-the-air update. Been using since more than 8 years, and helps you to download software features. Also after SOP, that is really disruptive technology. And then CAE and some other things like less administration or agile development, Scrum, and so on, design thinking and digital twin. So what makes CAE interesting? I have a little example. So assume that we have to extend the range. This one thing that everybody complains with electric vehicles, and we have to extend the range and with some additional 2 kilowatts. So assume the battery price is with 100 euros per kilowatt hour, and assume that we produce 300,000 units, lifetime is 7 years, million euros, and we generate additional weight sources. And if we take half of 0.5% for CAE, which will be really a huge amount of money for with respect of CAE, with 2 million, and in that case doing by computer-aided engineering or rolling resistance or energy management, whatever, HVAC efficiency. then it's really a smart way. And we see this that these new players are playing with this tool really extensively. So the question is, when we would like to use CAE more intensively with respect of strategic tool, what challenges CAE faces? One challenge is that CAE has to follow the innovation speed. The other one is to increase the process speed and to increase the efficiency. So when we have a look at what happens in the automotive industry, we see that the rate of changes is accelerating dramatically. So, and virtual development has to follow this pace. And even perhaps in the future, it is, as we just, Mr. Hodach spoke about the pull and push principle, maybe the virtual development process will even not only push by, but that will influence the vehicle technology in the future by using artificial intelligence, machine learning processes and technologies. So CAE is an integral part of the development process and has therefore to reflect future vehicle technologies. So it has to work hand in hand with the design process, with testing and so on. So what happens very often, this I've tried to show in this slide, is that we need some information that we have to represent and to be prepared. Otherwise, our toolbox will not be filled. And then we have a little problem with speed, because we have to do everything by the classical experimental test. And the tricky thing is that normally the budget is released for a new project when the project starts, but we have to start a little bit earlier for validation and procurement, whatever, or development of these CAE methods. So you need a separate budget, a couple of years, months, whatever, before. So what the process be? What can we do here? What is the typical process? We have an initial design, then we put all the data into numerical simulation, and the responsible person, the developer, has to wait then until the result is available. But he will not stop thinking. So we are here on a critical path. And because of the time restrictions I only have selected some ideas what we can do to speed up the numerical simulation. Because one problem is that the complexity is even increasing, and because we have Mr. Hodach just mentioned this, a lot of legal requirements, different standards to fulfill. This little machine is rotating even faster. Yeah, when this process, as part of the development process in general, this CAE process is divided in three main parts: pre-processing, fill in all the data you need, then you have the computer, which solves all the equations, and then you have post-processing to visualize, and you have the animations and things like this, the output. So the efficiency is output divided by effort. So what are the parameters we have? And I think we have 5 parameters. So this is the infrastructure that we need, methods and tools, then the process itself, then the organization, and what's extremely important besides of organization is culture. So I would think also in this order the importance is growing. So a little example what happens with infrastructure. Normally we have more and more guys creating software and writing some software in the office. What we have with driving simulators, we have central facilities where you have a driving simulator. When you think about ADAS, for example, this with hill and sill, etc. Then you have to wait. You have to book such a facility, a central facility, and what comes waste time. So the idea is just now to have a downsized later directly positioned at the desk side driving simulator. Something, it's a little bit the idea of a personal computer. In the past, you had these host centralized big computers, and you had a terminal. And what we have today, we have personal computers. We have directly we have access to everything what we need, and what is centralized is computing. And we could do the same here. That helps that the engineer using some software can directly test this directly in the office. So the other example is with methods and tools. Perhaps we can do some simulation a little bit, similar. What we have in the phase of the development process, we very often very detailed models. And these detailed models are a little bit difficult to handle. The question is, can we use concept models, for example, which are not so detailed, but we generate results extremely fast. So the accuracy is not that good, perhaps 3 or 4% less, but we are much faster, and we have a lot of tools helping us to do this in the right time. This is also a good example where we can save a lot of time. The other is process, and we think about process and doing things faster. We think about automation. We have a lot already available building like automation and parameterized CAD tools. Sorry, on my. Yeah, and we have multidisciplinary tools. We have simulation data management, machine learning, robustness, high performance computers, everything that we need here to for the automation of the processes. And this will be done in the future. The future has already begun. I say 4 years ago when we started with this process, and now we see that this is really a extremely good path into the future. But experience will then be in the computer, and we have to handle all this. How can we increase the efficiency?
Ask for conclusions.
I'm almost finished. We can have simplified usability. We can have centralized data. We can use like a digital prototype factory. We do things to get all the others. But what is extremely important, and this is my last chart, the car-career conflict, which means is something good for the car, good for my career, then do it. But if it is bad for the car and it's good for my career, you shouldn't. It is the process, it harms the development, and this is very often done. So my last slide, it is not the big that eat the small, but rather the fast that eat the slow. Okay, thank you.
very much, Mr. Gable, especially for this conclusive slide. I think that we all are now trying to find compromise between individual and societal issue solving. And yeah, I hope we will have possibilities to discuss it.
Yeah, John.
Thank you. And now I would like to pass the floor to continue with driving issues. So please, floor is yours.
Good morning, everyone. I'm Dino Flora from Qualcomm. I'm Vice President Technology, and I oversee Qualcomm product and technologies for Europe. I've prepared slides to go over the excitement of the deployment of 5G and how this will have a transformational impact thanks to the autonomous driving we will have in the cars and in the transportation system. First of all, it's an exciting time we're living on because we are at the time where we are been launching 5G since last year, and whereas in the first couple of years has been about launching 5G for smartphones, mobile broadband use cases, we're also seeing now a very fast adoption of the technology in the car ecosystem. If you compare with what happened in the 4G days, there is a tremendous adoption rate. We are already working on about 20 projects with different car automakers that will bring 5G capabilities on the road in the 2021-2023 timeframe. So way faster adoption than the 4G. And from a Qualcomm point of view, we are approaching this new era of the car from 4 key areas. One is the telematics and the C-V2X, bringing the 5G connectivity as well as the car-to-everything connectivity, C-V2X, which I will speak about it a bit later. We are also seeing a transformation of the cockpit, what we call the digital cockpit, as well as for infotainment reasons, as well as for some assistance reasons like a driver and occupant monitoring and things like that. We are also introducing a car-to-cloud service where the cloud connectivity will allow to do more agile over-the-air updates to the car. It will allow also car manufacturers to manage the different SKUs worldwide and so on and so forth. And finally, the big area where we are opening up is the area of ADAS and autonomous driving. Obviously, this is something that most of the industry is working on, and we are very excited to provide our contribution with our platform solutions. The way we look at the 5G area is not as a single connectivity capability getting into the car. The car it will be hosting a host of heterogeneous connectivity capabilities, starting from the C-V2X capability I mentioned before, allowing the car to communicate with other cars, as well as with infrastructure around that, as well as the 5G connectivity, which could be used for infotainment services, as well as OEM services like diagnostics or other services like that. But also in the car, you will have capabilities like Bluetooth, more and more Wi-Fi 6 we are introducing, and advanced positioning that it will allow you lane level accuracy everywhere, which will again improve the driving experience in the car. A key also element that is entering the car is artificial intelligence, where more and more functions of the car will be processed by AI and machine learning, and more specifically, the autonomous driving is the more obvious because it's all about obviously machine learning and starting from fusing sensors and try to understand the sensor to deciding actions based on that, as well as the smart transportation. So it's not only the car that will become more intelligent, also the infrastructure around will will be more intelligent, and the car will help the infrastructure to become more intelligent. We'll see later a little bit more about that, as well as there will be a more intelligent cockpit in dealing with the human interaction, as well as monitoring driver behaviors, as we said before. And the cloud connectivity will allow also that level of intelligence in coordination with the cloud capabilities. And because of this pervasive artificial intelligence touching many aspects of the car, many aspects of the compute system of the car, in Qualcomm we are proposing a platform for which enables efficiently scaling AI for the different use cases. And for the case of the car, it's a mobile system in a way, so it has to be done in a very energy efficient way. So it's not the AI which we also were working on for hyperscalers or servers. So in the car as well as in phones, it has to be done in a very energy efficient. So we are proposing a framework which allows to scale the different use cases from the very computer intensive to the one that had to be very power efficient. So it's important to understand that. And as a Qualcomm, we are well positioned to address this problem coming from the smartphone background and then applying all that know-how also to the car. So we have introduced a Snapdragon Ride platform, which will allow to enable autonomous driving and different level of autonomies. This is a family of system on chips and an inference accelerator for machine learning. Just to signal how important machine learning will be, this platform will have an entire chip dedicated to inference accelerator. So we can do that, all these inferences going on in a very efficient way. And as I was saying before, one of the first things the system will have to do is to deal with all these sensors and fuse them and try to understand plan behaviors based on these different sensors. As I was mentioning before, the car will be intelligent, but also the infrastructure. The way we are envisioning this transformation is also that the infrastructure, the city infrastructure, the road infrastructure around it will be also becoming more intelligent. We are envisioning that there will be, for example, you can have traffic lights which can have a roadside unit with an AI-based camera which could detect hazard situation like a pedestrian which is about to cross the road or is distracted. And thanks to the B2P, B2I connectivity, alert the pedestrian or alert the car so that this hazard situation can be avoided. And this is in a short range hazard situation. Also, the cloud could then help avoid longer range hazard situation. And this is somehow we have to imagine the infrastructure around as something intelligent, helping the car making decision on longer range and on the trajectory, on the paths to follow, as well as shorter range, avoiding hazard situation like hitting a pedestrian or so on and so forth. And it's a very exciting future where we're gonna rethink the car, the infrastructure around that, and the interaction between the two. And this is what I wanted to present today.
Thank you very much for very dense presentation focusing the main issues of autonomous driving and of course for the very, very perfect timing of your lecture. So that is time for Dirk Lappe, who would speak about digital transformation, which is very complementary to all issues mentioned in previous presentations. So Dirk, floor is yours. Virtual floor is yours, of course. Please unmute yourself.
What can I do? Can somebody else unmute me at the moment, please? Sorry for that.
Yes, you are unmuted, and please use F5 or this for the full screen presentation.
So does it work now?
It shares now both presenter and main presentation.
Sorry, I don't know. This doesn't work at the moment.
Just switch between your screens, please.
Yeah.
Sorry?
Switch between your screens.
How do I switch between my screens?
You are sharing the presentation.
Do you hear me now? Hello?
Click on the second, on the left side, on the top. Click on the Ansel's second tool. Ansel, I don't speak German, sorry. No, on the left side. Go left.
I think I'm completely out now.
Start sharing your presentation. Press F5.
Yes. Now I have F5.
And click on Anzeigenstellungen.
Yeah, okay.
And switch between the screens. Yes. Now you can start. Thank you.
Do you hear my voice? Do you hear my voice?
Yes.
Okay, thank you. Sorry, I was all the time muted. Sorry for that. So I start. Currently, the automotive industry is driven by major changes. Ivan Hodak just presented, so let's describe very detailed the actual situation. Besides the fact that we have this regulatory framework around us, as engineers and as if you are developing cars for the future, we have to follow also the money streams. And from this perspective, I would like to share with you the actual investments from Volkswagen, which are planned for the next coming years. And these main investments go in the direction of e-mobility, hybridization, and digitalization. There's so many efforts and so much money that from our perspective, it's impossible to do this all with new engineers coming from the universities. We have to transform also not the product, but we have to also help our existing engineers to consider that they are not working in the same direction as the past 10 years. They have also to switch and to swap into complete new areas. What we need is something like flexible specialists, which are changing with all the roots and all the background that they have, all the mechanical background, also and have a look into the digitalization. And this is I think the most complicated task that we have all in front of us. An engineer today can not work the next 5 years at the same topic as it was in the past. He has to learn much more as in the past in order to concentrate on what is happening in this transformation process. This is not really new. If you look back, at the beginning we had pure mechanical systems in our cars. Then there was an evolution to mechatronic systems. Everybody remember that maybe. Then came the first lane departure warnings and things like that, driver assistance systems. Connectivity became more advanced. And in the future, we will have now big data and cloud connected, and we will end up in automated driving. This process leads to much more technical complexity and to much more need of software. It is only 11 years ago where Porsche, Christoph, you will remember that, decided to make the first PHEV car. At that time, just 1 year before, PHEV was seen as not important, but in 11 years ago, the first PHEV was decided. And at that time, it was impossible to think about that Porsche really wants a BEV. Meanwhile, we have the first Porsche BEV, and this shows the disruptive what is happening in this area now, because we have now a car. At the moment, we have now a car which is completely new. It has so much software inside. If you look at the different components, we have things like a Porsche Intelligent Range Manager. This is mainly driven by software. The recuperation of that car is mainly driven by software. For the suspension, it's in addition to the mechanical components, the complete driving behavior of the car is driven by software. The performance, the complete aerodynamics, everything is based on a very powerful hardware, but mainly driven by software. And this will grow over the years and will become more and more important for the future. That is the reason why, from an engineering perspective, we have different fields for strategic development. We look strongly at vehicle dynamics, at advanced driving systems, automated driving, and mobility in the complete sense, from battery to e-drive is important. Infotainment, there was already a speech before, connectivity, but what we should not forget in developing software, and that is very important, is we should also look at the processes. So we have to deliver software in a very high quality. Software becomes more and more complex, and the minimum level for serious software is ASPICE level 2. And we should not forget in software development to concentrate also on these quality issues. In the second half of my speech, I would like to mention that we use today for timing and efficiency. Christoph Gümbel, you had also very nice input for me here. Is we use artificial intelligence in different ways. We use artificial intelligence for automated testing, but we use it also inside the car for functional components. And finally, of course, we need artificial intelligence to achieve autonomous driving with a level higher than 3. I'll give you some examples out of the development. It has also to do with what Christoph Gümbel presented, process speed. We use cloud computing. Here's a simple example. Typically, from out of a test car, it takes 5 days until the first results on the working desk of an engineer are available. It has to do with the data transfer, data selection, data evaluation, and then the data processing. What we have started now is that we made interviews with the experts, and we made into cloud intelligent systems, which are doing a lot of the work which normally an engineer would do inside the car, could be done offsite from the working desk. That would mean that in one test drive via this COMBOX, the complete data is collected. There's data analytics, and the complete data is in the cloud. And later on, the engineer can, without sitting in the car, can extract all the information he needs. And this reduces a lot of money, and is a very complex and intelligent system. The trick here is that we have the information that normally the human is taking in a 5 days period in the cloud as an automated process. The next example is also very interesting. Currently, we have products in the market for adaptive cruise control, and these product is normally relatively uncomfortable because in case of a cut-in, this could be safety critical. The car has to react in advance. And in order to have some security gap in the timing, it is in most cases it breaks too hard and it breaks too early. By using artificial intelligence, which is analyzing the scenery, we can be much faster, up to 2 seconds faster, and cut-in detection can be realized and seen by the car and can react safe and secure. But how can we define such corner cases, such as a cut-in detection? If you look, for example, this is a very simple example. We have here the 3 cars. It's my own car, my ego car, the actual leading car, which my adaptive cruise control is taking the distance, and here's a car which will probably do a cut-in in a few milliseconds. If this happens, suddenly this car is in the situation to be the leading car, and the distance between these 2 cars has been new calculated. And what is important, that also the lines where the car is in between are still the same. So this is one corner case. You can also think about corner cases where a motorcycle is in the shadow of a truck and is coming out, and in order to have a product, you have so many multiple permutations of these situations that it's impossible to do that in real time in real tests. That is the reason why we using much more corner case detection and use then software to produce hundreds of thousands of such corner cases for the development. The extension of that is that we realize inside the car, we have an intelligence inside the car for the testing, where we make an analysis with artificial intelligence in order to extract the data before they are transmitted to the cloud and to the test engineer. By making an analysis inside the car, and this analysis, for example, detects if a pothole is detected, for example, then not the complete video from the drive will be transmitted to the cloud, but only this type of video which shows the pothole and the reaction of the chassis on this pothole. And again, the engineer on this working desk can make an extract. So there's one test drive, and you can have 5 or 6 results out of the drive without being in the car yourself. I would like to show now, before I finish my speech, a small video which shows the elevation data, the test cases, and the vehicle simulation and the road data. And these are combined in such a way that from hundreds of corner cases, a neural network is taught and finds finally its way into the final product. I hope this starts. Funny. It starts. Elevation data, test cases, vehicle simulation, road data. Now we define the first corner case. This is collected. And out of this scenery, we produce now many more with different light, different shadows, rain, fog, whatever you can want to have. And we train with this scenery a neural network. This is simulation data. and this could be then used in the real car in the real drive. So what happens here in the simulation will be also available in the real car, and there's in the look and feel no difference between the virtual environment and the real environment. I would like to finish my speech with a short summary. In the future, and already today, there's a development process where the real car is using virtual sensors, virtual actors. In the development, we could use a complete car model inside a virtual environment. The way of working here is sometimes a little bit like working for a computer game, because you have the real car here, virtual persons, and you can always swap between real information, virtual information, in order to reduce as many training kilometers on the real street and to reduce costs as much as possible. For the future of the development and the transformation process, I would like that you take 3 words home for that. We will be in the future much more digital. The products will become much more premium because of these new software and development components. And of course, the cars will be much more connected. Thank you very much.
Thank you very much, Dirk, for this very comprehensive and very inspiring presentation.
Thank you.
I would like to inform all from audience that there is a possibility to write questions for all of our presenters. The discussion will start after the last presentation, which will be held now by Martin Hrdlička, and who will focus on mobility mobility in powertrain context. It means interaction between vehicles and the services which are needed by mobility environments. So please, Martin, the virtual floor is yours.
Hello. Vidíte všechno? My side. Can you hear me, please? So, hello, Jan. I would like to show you my presentation, and it will be more general presentation about drivetrains in a general context and mobility in general context. The vehicle age, the vast majority of passenger cars currently in the Czech Republic are combustion engine vehicles. There are about 6 million passenger cars registered in our country, and their average age is nearly 15 years. So Czech Republic has one of the oldest fleets in the European Union. Most of the vehicles that are part of this fleet do not meet even the EU2 or EU3 emission standards, and many of them do not meet any limits. So the other countries in the European Union, you can see on this ECE page. Gases emitted into the atmosphere can be simply categorized as a human harmful and planet harmful. So, in other words, locally harmful and globally harmful. The European Commission uses the EU emission legislation to address gas emission limits and limits for solid particles emitted in the atmosphere. exclusively during vehicle operation. EU emission legislation history is very interesting. As you can see, the start with EU Euro 0 1970 was based only on 20 pages. Euro 4 has already 10 times more pages, and latest legislation, EU 6 AP, has 100 times more pages, together with real drive emission and WLTP. The emission legislation is a not easy text, as you can see in the bubble. It is an example of a typical text. It is a not easy text, and for a technician, a technician normally couldn't understand. So it is necessary to interpretate this text to have a clear idea what influence will have this legislation to the product design, to production facilities, laboratory equipment, quality department, etc. The emission standards developed also in their time or over the time, and on this page I would like to explain two important factors, which is validity time of a legislation. As you can see, EU6W was valid for almost 4 years, and time from legislation approval to entry into force. EU6W was approved in 2012, and EU6W entered into force 2014. So we had 2 years time to prepare all quality production, design of engines, and so on. Both timelines are shorter, so the time for legislation approval to entry in force, as you can see, could be also only weeks, and with the changes in the last 3 years, we have every year a new legislation. The consequences are not only that we have to homologate every year, but we have to develop new hardware, new software, we have to invest, and of course the amortization is a big for our economics. The next point is the legislation is not the same in the whole world. As you can see, on an example of petrol engines, this chart is very colorful due to petrol quality, climatic conditions, politics, market protection, and also people purchasing living standards. We have a really colorful life in point of legislation. So in China, C6B with RDE, in India, Bharat stage 6, stage A, as you can see, Africa, EU1, EU2, or not emissions legislation, and so on. To explain the linear relation between CO2 and fuel consumption by way of an example, I would like to use a vivid imagination of a typical Czech example, which is a shot of spirit, alcohol. It means based on the tank to wheel, 1 gram of CO2 per kilometer is 1.04 liter per 100 kilometer. It means if you have a fuel consumption of 4 liter petrol per 100 kilometer, it means it is you emit 100 gram CO2. So every time if you will drink a shot, you can remember this example. The CO2 is not a part of EU6, but the European Commission and European Parliament decided to for limits and penalties to the CO2 average fleet from which will be accounted from fleet sold cars in European Union. The simply mathematic formula you can see in the right side of this page. And this red line starting 2019 with Škoda average CO2 fleet, we will be limited by the European Union starting 2020 to 95 gram, which means 3.8 liter per 100 kilometer. Some measures we can help with the conventional measures, but you can see it is not possible to achieve 95 grams. So electrification of a vehicle is necessary because the EU Commission per definition take a battery electric vehicle with a zero CO2 emissions because it is the premise of tank to wheel evaluation. So you can very easily account how many electric vehicles it's necessary to sell in European Union to achieve a limit of 95 or later 76 and or 2057. I think in the next year, in June 2021, is planned a check and then discussion about the year 25 and 30 and I think the European Commission would like to have a stronger limits. The next point are cities and air quality, not only CO2. And we have EU legislation, but there are also hygienic standards for air quality in the cities, and there are discussions about, for example, diesel cars couldn't or are prohibited of city centers entrance, and so restrictions and so on. The discussions is very interesting because the corona lockdown implicated almost no traffic in the cities, and the surprise was that the NOx and particles didn't decrease. At least the correlation traffic and NOx is maybe not so strong as was the assumption. Some cigarette or advanced breath produce 10 or 100 times more NOx, and on this point, I would like to only show that these hygienic standards are important, but the air quality is also a relative discussion. The people and the welfare, the living standard and prosperity in the world is also a big topic for traffic. The population has on planet has 7.7 billion, which is twice more than was on the planet when I was born 50 years ago. And in some, I think there are 1.3 billion passenger cars on the planet, on the different places. Only to imagine in the 1994 in the India was registered 6 million cars, and as I mentioned on the start of my presentation, these days in Czech Republic we registered 6 million cars. These days in India they registered 24 million cars, and about 5 million cars India produces every year. So the public transport increases not only because of the population increase, welfare and the prosperity is higher. The economy is, of course, an important accent, and the Czech Republic is a very good example for it. The share of Czech Republic on GDP is 9%, which is the highest share in the world. The Germany has 4.5, so it depends on automotive industry twice more than country as Germany. If you see on the right side, if we account the Czech Republic volumes of production of new passenger cars in Slovakia, we have 2.5 million cars in sum, which is per head the high density six people per car in the world. The share on the export in Czech Republic is 27%, and the automotive industry has about 500,000 people in Czech Republic. So it is a very important, the automotive industry has a very important economic impact. The powertrains in the last year okay, so the diversity of powertrains is really high. With internal combustion over the hybrid electric vehicles to electric vehicles, and we will meet really diverse powertrains on the roads in the next year. The energy carrier is also a big topic. As you can see, the energy densities of the different fuels and batteries have a big impact and big influence also on drivetrain solutions. So the alternative solutions and the aspects how to deal with the smallest molecule of Earth in the universe on 700 bar or other topics are really interesting for design and safety. The conventional physics how to achieve the lower energy consumption are clear. The alternative fuels are also already on the market, and I would like only to focus on e-fuels, so the fuels which are produced with help of clean energy, which is of course air, sun, or atomic power, and then we can also reduce use the CO2 as a input. But resources are also necessary to mention, not only on the right side the Balaton Lake, because I counted that the people consume every year 4 Balaton lakes full of oil. But on the other side, it is important to say a silver mine, which has a surface of 60 kilometer squares, would be needed 130 such mines to have a clean energy, or cobalt mines in Congo, and so on. So it is still the point, resources important, and strategically I think at the moment mostly China is the owner of mining rights in Congo, South Africa, and so on. Electricity production have to be clean. Of course, you can see here what is the situation in Europe. Based on the German, and it is last slide, but based on the German mix in the plug, you can see the difference internal combustion engine, plug-in hybrid, battery electric vehicle, what is the CO2 consumption in tons for a car which could run 150,000 kilometers. You can see the mix in Germany these days shows that the battery electric vehicle has the lowest CO2 production. Also, the plug-in hybrid is not so bad. We accounted 50% usage of electric transport with this car. But if we will use clean energy, a clean energy mix, we can see that the effect on all kinds of cars is similar. So the assumption is, or the conclusion is that rather than a drive type, determining factor behind the carbon neutrality is the energy mix in the plug. Thank you.
Thank you, Martin, for this very informative. And just now we can start questions and answers. I would like again to encourage all in audience to ask questions, but I have responsible for assigning the existing questions to members. So I'd like to start with Ivan. Then I think everybody of you can something to it. The question, my interpretation of the question is, what do you think about the possibilities of bridging gaps between different countries and different societal groups in the future, considering this different mobility caused by different infrastructures, different costs for and so on. Do you think is converging or not?
Thank you very much, and I'm happy that my voice is back. It was not very pleasant. I think that the mobility issues will have solutions that will be local solutions. We will not be solving the same problem, the problems in the same way as they are solving them in Shanghai. You cannot apply to Prague and to Brussels and to other places. We can we can solve the mobility problems here by taxes, taxes to access to cities and things like that, and developing the car sharing. We will not be able to do what Shanghai, Beijing, and the Chinese are doing. Basically, not to sell not to give you the possibility to register the vehicle. But what we can do and what we should do is we should learn from each other. We should see the best practices, what is happening in the different places in the world. And for that, I think FISITA and other organizations should be instrumental to exchange the best practices. We don't have to use them, but it's important. So that's the first thing. That's how I bridge it. We are not going to harmonize the mobility solutions across the globe. But what we can harmonize are a number of technical issues, technical solutions. There is no reason why we should make different cars for China, for the United States, for Japan, and for Europe. We would save money to the industry, save money to the consumer, and we can use the money for research and development and for the new technologies. And we have tried this in the TTIP negotiation, in the negotiation with the United States. I hope it will come back with the new American administration, because during the Trump era it was a disaster, this cooperation. I'm not saying that there was no cooperation among the companies. I'm talking about the member state, the countries, and we have to watch very carefully what is happening in the Pacific Rim, because in the Pacific Rim, with the new trade deal that the Chinese have just concluded with 15 other countries, and there is a clause about India. They will start developing standards, and we will have to copy them. So the easy kind of the low-hanging fruits, the charging and the technical issues we can do. Emissions will be much more difficult, and the most difficult but most promising is to look into the possibility of harmonizing standards for autonomous vehicles. It's makes no sense to shuffle these cars up and down and each time do a new one. So it's a global solution, but adapted on the local to the local situation.
Thank you very much. Just now, I would ask Dino, Christoph, maybe even Dirk, on the energy efficiency of information use and computations. If I may, what I have understood from this question is that we are facing now very strange situation, very new situation, and maybe strange situation, because the computational power requirements are higher and higher during research, during development, and even during car driving. So I will start with Dino. I would please Christoph and Dirk.
Correct. So as the car gets more connected, and there are different forms of connectivity, as the compute capability exponentially increase, because again, there is the infotainment piece, the diagnostics, the digital cockpit. There will be a lot of machine learning and AI in the car. The compute capability will increase. There is a big need, and the car is a mobile system in a way. It's the ultimate mobile system, as Steve Jobs would say. It needs to be done in a power efficient way, much more than a data center. You cannot imagine to employ architectures that are used in the hyperscalers, web giants using in data centers. You really have to think in terms of mobile devices and very power efficient architectures. And that's what we research with Qualcomm. Again, applying a lot of the learnings we've done on the smartphones now in the car, which is a completely different system, but still fundamentally is a mobile system, needs incredible level of efficiencies.
Thank you.
Yeah, from my point of view, I would think we have two situations. One situation is perhaps within the car. So within the car, power consumption plays a big role. Redundancy plays a big role. When you are using computing power during the development process, I think the most important issue is flexibility and that you can grow as fast as needed. And in this case, I think some solutions that we have with supercomputers that are available in the cloud, what Rescale is for example, is doing, that is something that is really good. Otherwise, you have so much administration, so much effort for the procurement that you will lose the race. But technically, it is possible to get access to the performance you need.
You and maybe Dirk. I think you are mute, Dirk.
Can you hear me?
Yes, now yes.
Fine, thank you for that. I think in a typical car, the range management, even in a battery-driven vehicle, the range management is an important issue. If you think about it, a typical car needs about approximately 140 watt-hours per kilometer. Then every watt that you are using for the computer network in the car is reducing the range. So there's an automatism that we on the development side try to reduce the watts coming from the computer network as much as possible. Typically, if you put all the computers together, we would start with approximately 800 watts to 1000 watts. And you can imagine 140 watt-hour for pure driving, 800 watts to 1000 watts for the computer network. This is reduced by a very clever method. So the computer is switched off if it's not needed. The air conditioning is working close together with the comfort abilities inside the car. And we try as much as possible to have efficiency wherever we can use it. Also, the thermal management inside the car is working close together with the energy management of the electrical system. So many engineers are working over 4 years in optimizing in such a development process the consuming power of the electric system. But there are limits. I think that the lower limit is just above 200 watt while the car is standing.
Thank you. The next question, I think that Martin can start with it, but it is for Martin and Dirk, in my understanding, and it is the extension of the current development methods to digitization, of course, to the life cycle of a car, especially for, say, Central and Eastern Europe, not speaking about India and Russia and other parts of the world. What I have understood, the second-hand car market is still very important, and it would be very nice if we can extend this, say, information on a car from the manufacturer whole life cycle. What do you think about it? First of all,
I think there are two aspects. The environmental aspect, of course, the cradle to grave point of view is very important, and I think it is the way how to respect and how to follow the carbon footprint in the future. So I think the European Union will start with this topic, but of course at the moment it is difficult because the legislation and all the penalties are coupled to tank to wheel, and it has of course some implications. But the second point of view is a economical point. The how the customer will understand, of course, the internal combustion engines, the interests from our customers is if they consume less from a tank, they pay less, and the costs, the operation costs from a car are lower. So of course. For us, it's necessary to follow both, not only in the European Union, but also in the emerging markets or other countries. And one point of view is the car producers and the governments are interested into or motivated to lower the carbon footprint, but not the customers at the moment. And it is necessary to look for how they will be motivated in the future.
Thank you. Thank you. And now, can you add something to this life cycle extension of the digitization in manufacturing, development and manufacturing process?
Maybe the most interesting thing is about the batteries, because battery is the biggest portion inside the car which needs to be recycled and used for a second life. And there are some concepts where we use the battery modules in the second life for energy storage. That is very interesting. So, and you replace the old modules by newer ones in the workshop, and use in the second life the battery modules. But meanwhile, we have processes where almost 100% of the resources inside the batteries can be reused. And I think in the future, later on, there will be most of the batteries most of the battery cells built by recycled components and content. In terms of the digital, it's very interesting. If you look at an Apple product, for example, or a mobile phone, it's a maximum lifetime of say 5 years. Our cars have to last more than 10 years. It's true. And what we are doing is we ensure that software updates and availability, and that is much more complicated in our business than in the consumer business, will be guaranteed also in the second life, of course. It should be secure. It should be protected. It should be protected against also aggressive software from outside. And but it's clear in the development plan that we take care of that.
Thank you very much. And
one last sentence to that. This problem is not new. We have existing products out in the market where there's a lot of electronics inside already. What we sometimes have to do is that we re-engineer an old component by adding a new computer processor inside, and make a new hardware available, which is also working for the older cars. Complicated.
Yeah. Thank you. And because we are approaching the close of time devoted to discussion, I have one simple question for all panelists. If you can tell us in one sentence how you compare the reliability in predictions of the future development in past and how it is in comparison to today's predictions. So if Ivan can start with it.
I have difficulties doing it. I'm sorry. Maybe that the technicians will have a better answer. But I have on this one, I have a lot of difficulties to do it.
I think
Then Christoph.
Yeah, what I would like to say is the problem we normally have is with prediction, we do normally a linear prediction. So when we think about what happened in the past 10 years ago, okay, it's not far away. 10 years from now, it seems to be that's far away, but it's not far away. And with respect of what we have to do with development, 5 years from now is today, and 10 years from now is tomorrow, more or less. So what did we predict? We can predict something that happens, but for example, with COVID-19, this is something that is unpredictable. But it's accelerating the complete process, I would say. Yeah.
Thank you. Dino?
So obviously, maybe very specific, but one of the most intriguing prediction in my mind of these days is when we will have full autonomy, level 5 autonomy, and that's the most exciting prediction in my mind. And on that, of course, there are very diverging opinions, from the very optimistic to the very a little bit more realistic, and then some pessimistic views. So it's wide open. So that prediction, that is the one exciting me most, is the most open at the moment in terms of possibility. I would side with the cautious optimistics camp, but again, it's a very wide open set of opinions.
Thank you, Dirk.
I would like to prolong Christoph Gümbel's argument a little bit. If you look from now 10 years or 15 years ahead, there will be no new technology which is not existing at the moment inside the cars. Because everything what is foreseen in the next 10, 15 years is available today as a product already, or as a research topic. There will be nothing new in 10 to 15 years because the cycle is relatively short. For the next, the products that Porsche will bring out for the next 8 years are always almost clear. We have a cycle plan. We are following this 4-year cycle. Every 4 years a new car. And in terms of batteries, it is for the range the most important part. All the technologies are on the table. For the connectivity, it depends a lot of the country. In China, there will be a different connectivity and a different Car2X approach as in Europe, and maybe also different in US. But we will be much more connected. The car will be much more integrated in a cloud-based system, and the range will be much higher from the cars. If the fuel cell will have finally the success, it's still an open issue for me. But in most of the other cases, I think there will be not so big surprises in the next 10 years. Thank you.
Thank you. One sentence would be enough. Martin?
so. I think it is different if I could answer to Europe, China, United States. So the world is really different, as we could see on the colorful page I showed you. So the drivetrains come with a higher diversity. It's definitive, depending on the economics and politics situation in the different regions in the world. I think also the energy industry will get a higher importance, not only because of clean energy, but also because of synthetic fuels. The battery electric vehicle are a topic for Europe because it's given by law and maybe China. But in the other parts of the world, I expect either other transport. The the mobility will be more expensive.
Thank you. I am not sure now whether Ivan had some technical difficulties of connection or technical difficulties in replying to this question. So one more the possibility.
I do agree. I think that I would like to use an example. In 2012, we were saying that 2020 we are going to see 10-15% of our because we don't have 5%, we don't have 3%. It's going to be different in different regions. Autonomous vehicles, we were saying 2025, 2030. They are predictions they speak about 2040. I think that the new technologies are coming with the speed of light, and they are coming much faster than before, and they are coming in different way in different regions. So I think the predictions should be made, if ever, the predictions should be made by regions, and they're extremely difficult and complicated. When you look back, we were almost always wrong.
Thank you very much. I hope that all of audience participants and all of us or all of you appreciate this very open discussion as much as I can appreciate it. And just to conclude, it is my task, and I must admit it is very hard task. What I found during this nice 2 hours is that the change will be being a steady state for all of us. No, we are all the time now in some transient period, and faster development may reach the limit, not only the limits of engineers, but I am afraid also the limits of public acceptance, public understanding. In such a situation, collaboration and teaching from experience from other part of the world is very important. And of course, the harmonization of conditions for all of us is a very needed condition for avoiding the world being broken into segments. And it is what we are not very keen on. I can say from my personal point of view. And I think that the portfolio of possible solutions should be enriched by promising potential concepts. We know it from investment that it is not very smart to invest to one direction or to one promising opportunity only. And the development driving factors should be very carefully evaluated, because sometimes the driving factor might be far real impacts, the real needs, and the real possibilities which are limited by the laws of nature. So it is how I could understood I could have understood today's intensive 2 hours. Before we conclude, I would ask Andrzej if we add some additional information on today, tomorrow, and the next September. We are all hoping that the postponed FISITA World Congress will take place in Prague. So please, Ondřej.
Excellent presentations. The moderator for his difficult task, all the participants for joining and very interesting discussion, and last but not least, also the scientific and technical committee together with the reviewers for their excellent job reviewing and selecting the technical content, and definitely also the colleagues of Czech Automotive Society for their continued support. I would also like to appreciate company Garant International for their care about the realization of this event. The Congress covers 10 topics with more than 60 technical papers, which will be available at the web of FISITA starting tomorrow. Please follow FISITA at Twitter or LinkedIn to get more information on the published papers. We have also recorded the keynote session. As soon as we will receive the commitment for the keynote speakers, we will share it with you. And last but not least, I would also like to acknowledge the sponsor of FISITA Web Congress 2020, the company ANSYS. However, the Web Congress 2020 is not the last event organized in collaboration of FISITA with the Czech Automotive Society. I am very proud to invite you to submit your abstract to the FISITA World Congress, which will be held in September 2021 in Prague, in the Czech Republic. The call for papers is open now. So we have 12 o'clock. The keynote session of the FISITA Web Congress 2020 is closed now. Thank you very much from my side and goodbye.
Goodbye, and thanks to all distinguished keynote speakers.
Thank you very much.
Thank you. Bye-bye.
Thank you. Bye.
Thank you so much, and bye-bye.